so supportive of us.
Kramer's rule, once you get to know it, you'll love it. This, people are indifferent. So what we're going to do is, first we have to create what's called the matrix of the coefficients, the coefficient matrix. Coefficient.
That's what that thing's called.
Matrix. You're going to put all the coefficients into a matrix, a 2x2, because this is a 2-variable system. So 2, 3, 5, -2. Make sure you include the sign. So if it's positive, it's going to be a positive number, and if there's a minus sign, it's going to be a negative number. Coefficient matrix.
Wait, where are all the y's and stuff?
Next, we make a variable matrix. Depending on what your variables are, you're going to stick them in to a 2x1 matrix. In some situations, we'll do 3x3 and it'll be a 3x1. But basically a column matrix with the first variable and then the second variable. You want to make sure that both equations are identical. They have to be in this form. Okay, so it's x plus y equals constant. If they're not in this form, you have to put them in this form. So for example, what I mean by that is, if this was y equals -2/3, x equals 1/3, or plus 1/3. Let's say this is what one of the equations looked like. You would have to fix this. First thing you would do is add the 2/3 x to put it over here. You would want to make sure that it was in front of the y. And then you could go from there. Like, you could actually use this, or you could multiply everything by 3, but you don't actually have to multiply everything by 3. As long as it's x plus y equals constant, you could just use this, okay? But it has to be in that form, so you don't want to start with y equals. Now, after you make your variable matrix, you're going to make, can you guess?
The answer.
A matrix of your constants, yeah, or your answer.
The constants, sorry.
The constant matrix. Constant matrix. So for us, that's 1 and 13. Okay. So everyone's seeing where these numbers are coming from. All right, so now what we have to do is we have our variables that we want to isolate, get by themselves, solve for, etc. We need this gone. Okay, so what we're going to do is, hold on, I'm going to rewrite this real quick.
Addison, he goes, I'll try. What? You're going to go burst keys. Because Jack can't drive.
Okay, so we are going to multiply by the inverse of this matrix. So we're taking this matrix, we want the inverse of it, and we're going to multiply on the left side of both sides of our equation.
Oh my god, I just wrote the same never mind.
The reason we want to do that is because these two, when put together, will make 1. 1, the identity matrix. 1, 0, 0, 1. 1, same thing. Okay, so since you have a quiz coming up,
what is our quiz?
Monday.
Oh god.
So since you have a quiz coming up on finding inverses by hand, we're going to do that. So we're going to find the inverse of the black matrix. Okay. The inverse of the black matrix. First you would do 1 over the determinant. So 1 over -4 minus 15. Then you multiply by these two swapped. So -2 goes up here and +2 goes down here. And then these two switch signs. They don't switch places, they only switch signs. So this would become a -3, this would become a -5. Okay. On the other side, we would do the same thing. We're still multiplying by the inverse matrix. So that's 1 over -19, -2, -3, -5, and 2. Okay. So the red is representing the inverse of the coefficient matrix. Okay, now, we don't have a calculator, so what we would do is multiply these two matrices together, and we should get 1. So let's see what that is. Well, we should get like the identity matrix. So we're gonna do -2 times 2, which is -4. Then we do -3 times 5, which is -15. We add those together, and we get -19. Then we're going to do this row with this column. So we're going to do 2 times 3, or
Where did you get the
-2 times 3.
-19 from again?
I just erased it.
Oh, God.
Then we're going to do -3 times -2, which is 6. Add those together.
0.
0. Got the first row, let's move to the second row. We're going to do -5 times 2, that's -10. And then 2 times 5 is 10. Add those together, 0. Okay, so now we got one more column. -5 times 3 is -15. -2 times, or +2 times -2 is -4. Add those together and you get -19. So that's what you get when you multiply these two matrices together. Remember, we have this here. Okay, we have to do the same thing on the other side. Multiply those matrices together. So we're going to do -2 plus -39. What's -2 plus -39? No? 1. I don't know why I put 2. I know, I meant to put 41, but then I saw the 2 and I was like, I don't know what I'm thinking.
Wait, it
Okay.
just goes in the middle?
Well, it's
Oh, you're
gonna
multiplying
be
those two together. Sorry, I was like looking at something.
it's a 2 by 1, it's a column matrix.
Yeah.
Okay, so let's do the bottom row. So we got -5 plus 26. What's -5 plus 26?
21. 21.
I almost did it again. Almost put 22. Okay. Now, what happens when you multiply -1 over 19 by these numbers in here?
1.
Yeah, you get 1, 0, 0, 1.
This is the longest problem we've ever done.
Now, what's 1, 0, 0, 1 times x? Y?
XY.
XY, because it's the identity matrix. Over here, we're just going to multiply those by 1 over 19. I don't think they go in. So you just get like 41 over 19, and I don't have enough room to write that there, so I'm just going to put it down here. You get 41 over 19 and 21 over 19. What that means is x is 41 over 19, and y is 21 over 19. Because 41 over 19, yeah. But see, imagine if we were solving this by substitution or elimination, how many fractions we would have to deal with. And here, we didn't really have to deal with them until the very end. We had nice, like, constants, whole number,
This is
integers,
like a
whatever.
Full, like, this is like a lot.
So now,
This is one quiz in itself.
Yes, literally.
but it's
that one
not.
question.
So,
But
all
it's
right.
not.
Listen,
Okay.
this step that we did here, all of this work,
Mm-hmm.
was just to verify that we found the right inverse matrix.
So can you learn just write 1, 0, 0, 1 since you know it's going to be like
You can,
Until it's not.
yes.
Thank you.
If you want to check your work and make sure you found the right inverse matrix, you'll do the whole thing. You can also just verify at some point, like on the test when you have a calculator, you just verify on your calculator that it's good.
Then when we do that, we
So what I want to see is I want to see the matrix equation. That's what this is, the matrix equation. Then you're going to show that you multiplied by the inverse. Okay. I want to see what the inverse is. So I want to know what the inverse matrix is, like this part. If you don't want to multiply by hand, you don't have to do that. So you don't have to like necessarily do this part. You can just skip right to, oh, it's the identity matrix. And then over here, if you have a calculator, you can do all of this on your calculator. If If you don't have a calculator, then you have to do it by hand, but it didn't take us very long to do this multiplication by hand. What I want to stress to you though is don't multiply by the 1/19 first and then do the multiplication. Do this multiplication first. It'll be easier, and then you multiply by the fraction, and you can deal with the fraction at the end. So I need to see the matrix equation. I need to see that you're multiplying by the inverse. I want to see the inverse somewhere, and then you can pretty much skip to the answer after that. I did all the steps for you because I wanted to show you like why it works. But moving forward, we're going to skip a lot of these steps, okay? And then moving forward even past that, you can use your calculator for a lot of these things. So I have been told that systems of equations are on the SAT, ACT, and you can use this method or what I'll teach you next week, which is Cramer's rule, to get the answer pretty quickly, because all of this can be done on your calculator. So that's what I'm going to show you next, is how you would do this on a calculator. So take your calculator out. So how can we do this quickly and efficiently on our calculators?
My chest is like itching.
Nah.
Because it's like gross.
So you have to know the steps. Like you can't just start doing stuff. But once we know,
Then I can't see.
It's just like peeling here on the side. It's like itching me.
Are you gonna make the same mistake?
once we know the matrix equation,
Okay.
once we know the matrix equation, we know that we need to multiply the inverse of this times this. That's all we're doing. I just showed a lot of steps, right? But in general, all we're doing is taking the inverse of this guy and multiplying it by this guy. So you'll create a 2x2 matrix. So right here, go to this guy, 2x2 matrix. And you'll put in your coefficients, 2, 3, 5, -2. Go outside your matrix, raise this to the -1 power. That is representing the inverse matrix. If you want to know what the inverse matrix is, you can press enter. Or not, okay? Or not.
Oh god, but I did. Wait, how did you bring that guy down again?
You go up, highlight what you want to copy and paste, and then press enter.
Highlight. Okay.
Now we want to multiply the inverse matrix
Oh.
by the column matrix 113. So column matrix, that's why this is here, because you often multiply by the column matrix. So 13, enter. Answer.
Oh, wow.
See how quick and easy it
That
is?
was
So if we
so
don't
much
have a
fun.
calculator on the quiz?
So I want to know that you understand the steps. Okay, the steps are important. And then I might throw in some extra steps in there, but this is how you would do it quickly and efficiently on the calculator. Your quiz does not cover inverse. This is not on there. It goes up to inverse matrix. What would be the variables that we're trying to figure out here?
RJW.
Okay, so R is the number of minutes run. I'm just abbreviating J. Number of minutes he needs to jog. And then W is the number of minutes he needs to walk. The first thing that they tell us is that he wants to do a total of 310 calories and a total of 40 minutes. So let's focus on the 310 calories. That's a number of calories.
Oh, I know. 12.5 R.
12.5 R
Plus 7.5 J.
plus 7.5 J.
Plus 3.5 W
Yes.
equals 310.
Good. So you take the calorie amounts, you multiply by the number of minutes he runs, jogs, and walks, and you set that equal to the total calories. That's equation number uno.
And then
And then,
R plus J plus W equals 40.
good.
Wow. Honestly.
So you take the number of minutes he runs, jogs, and walks, and you set that equal to the total minutes he wants to do stuff. He doesn't have a lot of time, guys. He gets home really late, he has to take care of his kid, he wants to go to bed. Oh wait, that's me.
Jim has a whole life story.
You got fired.
Then we have one more, and that's this one.
Oh,
What?
there's
Do
another one.
we replace J with 2R?
No, don't do that. We want 3. But we want to jog twice as much as he runs. So that's our third equation. Jogging twice as much as he runs.
Is it
2J
equals
Is it 2 or English?
W plus W? Oh, whoa.
It's either this or this.
First
Let's
one.
plug in some numbers.
First one.
Okay, so if J is 10, R is 20. Does that make sense? If J is 10, R
No,
is
because
20.
he's trying to
no,
jog
it's equal
twice.
to each other.
So,
It's like
What?
20 equals
No,
20.
but if J is 10 minutes, then that means R is 20
no.
minutes.
Then it's
No,
two.
that's bad.
It's two. It's the
Okay, so
J
if
equals to R.
if J is 10, then that means R would have to be 5. Is he jogging twice as much as he's running?
Yeah.
Okay, so it's this one. J equals 2R. J equals 2R. Now, do you see how that third equation looks nothing like our other equations?
So
That's
Plug
a
it in.
problem.
Oh.
This is where it came from, okay? We need to adjust it so that it looks like these. It has to look like R, J, W. They have to be in the
can you just
exact
say
same
negative
order.
2R plus J equals 0?
Yeah, and so we would need to put the R on the left. And we would also need it to go in front of the J because these R's are in front of their J's. And they all need to be the same order. So we're gonna do negative 2R plus J equals 0. Now,
Great.
when we make a coefficient matrix, we have coefficients in here. I need coefficients. What's the coefficient here?
1.
What's the coefficient here?
1.
Here? Here.
1.
What about here?
1. 0.
0.
I don't know.
0.
Help.
You have to have a coefficient for every place in the coefficient
I just like
matrix.
glitched.
You
Did anyone
can't
see?
leave anything blank. If it's not there, you fill in a 0 because it's not there. But you can't just not put something there. When you have a 3 by 3 matrix, all the elements need to be filled in. Does that make sense?
Yeah.
If you're missing a variable, you put in a 0. So we have our system of equations. Now we're going to write coefficient matrix. 12.5, 7.5, 3.5.
Can you is this easy?
Yeah.
Okay.
Well, I don't know. To do?
Yeah.
So easy because we're going to use our calculator.
Yeah. Are we always gonna use our calculators for this problem?
We don't know how to find inverses of 3 by 3 matrices by hand.
So yes.
So yes.
Cool. Negative 2 is the other one. Yeah.
Okay.
RJW.
The hardest part is writing the equations. Then the next hardest part is making sure that you put them in a way that can be mathed. Okay?
Right.
A way that makes sense and is uniform in a
Put
certain
my
way.
stapler in Jello.
Ew, I know. Get the jello.
It
They
has
made
one.
the Jello.
So
Yeah.
here's the thing. If like Luke is doing this question and Emma's doing this question and Victoria's doing this question in different areas, maybe they put their equations in a different order and therefore their matrix might look completely different because this would be here and the rows might be in a different order. Sometimes your equations can be different and your matrix will look different. It's not necessarily wrong, okay? So there are, just like with substitution and elimination, multiple ways you can do this question correctly. Don't think that just because yours looks different from someone else's that it's wrong. It just matters that the variables are in order, okay? That's key. Variables are in order. You have a coefficient for everything, and that obviously your original equations were correct. So if you screwed it up and did this one, obviously you're gonna get the wrong answer. Usually you'll know very quickly that you got the wrong answer because for this question, you'll get like crazy decimals or something maybe. And not to say that decimals are wrong, but for this particular question, it's probably wrong. Now, what we do after this is, what's the concept? Like, how do we get this by itself?
Inverse.
Which inverse do we want to find?
The first one. Yeah. Not
Yeah.
him. That
This
one.
guy, him. The inverse of the coefficient matrix. So what we're going to show on paper is we're going to say RJW is going to be equal to the inverse of our coefficient matrix, which is this one. So inverse of this times the constant matrix. And then we're going to just plug that into our calculator exactly as you see it there. So the hard part, like I said, you write the equations, then the next hardest part is you have to put it as a matrix equation in the appropriate way, in an appropriate way I should say, because there's multiple ways. And then you're going to type it in your calculator. So you're going to get a 3 variable matrix, or a 3 by 3 matrix, and plug in your coefficients. And so the reason this is better than substitution or elimination is got a lot of decimals in there, and that's annoying, right?
Right?
We don't have to deal with it. We're going to raise this to the -1 power. Don't forget that part. That's really crucial. Otherwise, you're not multiplying by the inverse. You're multiplying by the matrix itself. Times, and then we're going to go back here and put in a column matrix with 3 rows,
10,
1 column, and put in 3, 10, 40, and 0.
10, 20, 10.
And hopefully, we get the answer.
Equals 10, J equals 20.
So I ran out of room a little bit here, but your final step would be this. And then you would say he would run 10 minutes, jog 20 minutes, and then walk 10 minutes.
I heard that.
Thank you.
Woo!
Yeah. You try.
So see how it's easy at the end because we're using the calculator, and we could have done that for the 2x2s, but I feel like we should practice the skills since you have a quiz Monday. Okay, questions?
Is there gonna be more
Yeah.
problems Monday?
Let's try it ourselves.